Hi, so welcome to the second algebra video. Again, like I said in the first video, I solved for this question already, but my audio was off. So I'm not going to rewrite all the working out, but it's not too bad. So this question asks us to prove that a certain expression can never be negative for all real values of x and y. Okay, so you'll see lots of questions like this in past papers. Again, it will usually be your last question, and it will be something like, why will this expression always give you a prime number? Or why will this sequence never be negative? Or why will this expression never be positive, for example? And so it will usually come down to you just simplifying the question, really just breaking it down, and then seeing what you can do from that step, and just take it step by step, okay? In this case, we see that we have this 2y squared. So I split that up into y squared plus y squared. Then from there, I see that these first three terms can actually be factorized. And so that's what I do. I factorize it into these two brackets, and my y squared just carries down. From there, we can see that we've got two identical brackets, and so the bracket just becomes squared. And so, as we know, y squared or x squared or any number squared will always give you a positive number, okay? And so that's what we see here. Okay, so regardless of the value of x or y, as long as it's a real number, so it can be a negative number, a decimal, a fraction, a positive number, anything. Okay, it can be as big as small as we like. It will always give us a value in here, and regardless of what that value is, it being squared means it will always be positive. And so if it's positive, it's above 0, right? And we use that same logic for this y squared here. And so when you're adding a number that will always be positive and add that to a number that will always be positive, we end up with an expression that will never be negative. Why? Because it will always be positive.